In this screencast, you're going to learn how to find the trig functions of any angle, not just angles in right triangles. So here's the deal. We're going to let theta be an angle in standard position, so that means that the initial side is on the positive x-axis right along here, with a point xy on the terminal side. So let's say that x comma y is on the terminal side of this angle theta, and r equals the square root of x squared plus y squared. So this is y and that's x. Then that means we define the sine of theta to be y over r, cosine of theta to be x over r, and tangent of theta to be y over x, provided that x is not equal to 0. Which also means that the reciprocal functions are very easy to find. Cosecant will be r over y. Secant will be r over x. And cotangent will be x over y. So let's see how this works with an example, okay? So this says that we're going to let our point be negative 3, 4 on the terminal side of theta. So let's draw a quick picture right here. Negative 1, negative 2, negative 3, 1, 2, 3, 4. So here's our point, negative 3, 4. And we're going to find sine, cosine, and tangent. So we need to get r, don't we? Okay, so by the Pythagorean theorem, r is equal to the square root of negative 3 squared plus 4 squared, which is equal to the square root of 9 plus 16, which is the square root of 25, or 5. So now I know x, I know y, and I know r. And that's everything we need to get sine, cosine, and tangent. So the sine of theta is just y over r. The cosine of theta is going to be x over r. And the tangent of theta is going to be y over x. Well, I said y and I wrote y, didn't I? Y is 4 and x is negative 3, so that'll make that whole thing negative. Okay? Okay, so in that previous example, you may have noticed that cosine and tangent are both negative. And if you look at this little chart here, you'll notice that all of them are positive in the first quadrant, and only sine is positive in the second quadrant, only tangent is positive in the third, and only cosine is positive in the fourth. So here's a nice little trick to remember that. All students take calculus. And what this means is all of the trig functions, sine, cosine, and tangent, are positive in the first. Sine is the only one that's positive in the second. Tangent is the only one positive in the third. And cosine is the only one positive in the fourth. Okay? So let's take that little trick and apply it to an example. Here we're given the tangent of an angle. We're told that it's negative 5 over 4, and we're also told that cosine is positive. So which quadrant would have a positive cosine and a negative tangent? That would have to be the fourth quadrant, where cosine's positive and everything else is negative. So that means since tangent is y over x, I've got negative 5, positive 4 right there, and now I can use that to find r. r is going to be the square root of 16 plus 25, which is the square root of 41. Okay, so now I have everything I need to find sine and secant. The sine of theta is going to be y over r. That's the square root of 41, not 41, right? And the secant of theta is going to be r over the adjacent, over x. So that's the square root of 41 over 4. So what we're doing is making use of things called reference angles, and here's what a reference angle is. If theta is a large angle, it's in the second or the third or the fourth quadrant, then we can find the trig functions for theta by using its reference angle. And a reference angle is the acute angle, theta prime, formed by the terminal side of theta and the horizontal axis. That's really important. You will never find a reference angle using a vertical axis. Reference angles are always measured from the horizontal axis, the nearest one. So if you have an angle in the second quadrant, you're going to get the reference angle by subtracting that angle from 180 if you're in degrees, or subtracting it from pi if you're in radians. If your reference angle is all the way around into the third quadrant, then you take the angle and subtract pi if you're in radians, or you subtract 180 if you're in degrees. And finally, if you're all the way around into the fourth quadrant, you're going to subtract that angle from 2 pi if you're in radians, or subtract it from 360 if you're in degrees. In each case, you're looking for this small angle right here that's measured to the nearest horizontal axis. So let's do some examples. Find the reference angle theta prime if theta is 300 degrees, 2.3 radians, or negative 135 degrees. Okay, well 300 degrees is between 270 and 360, because remember this is 0, 90, 180, 270, and 360. So 300 is somewhere in here. So there's theta. That means that our reference angle is going to be 360 minus 300, which is 60 degrees. Okay, how about problem B? If theta is 2.3 radians, well, 2.3 radians is between pi over 2 radians, it's about 1.5 something, and pi radians, which is 3.1 something. So here is 2.3 radians. That means that we're going to subtract 2.3 from pi to get theta prime. So theta prime is going to be pi minus 2.3. And let's do that on our calculator here. So I'm going to go second pi minus 2.3. And we get 0.8416. 0.8416 radians for the reference angle. All right, and the last one is C. So here theta is negative 135 degrees. Since it's negative, we're going to go in a clockwise direction, and we're going to end up in the quadrant down here. Okay, so I am going to go 180 minus 135, which is going to give me 45 degrees. Okay, that's the reference angle for negative 135. So let's put all this together. How to find the value of a trig function of any angle theta. First of all, determine the function value for the reference angle of theta. And then, depending on which quadrant theta is in, you make that function value either positive or negative by remembering your all students take calculus trick. Okay? So let's apply it to some problems here. The cosine of 4 pi over 3. Okay, so 4 pi over 3 is a pi over 3 more than pi. It's over here. So my reference angle is going to be 4 pi over 3 minus pi, which is 4 pi over 3 minus 3 pi over 3, which is 1 pi over 3. So the cosine of pi over 3 I have memorized from the unit circle, and that is equal to 1/2. However, we're in the third quadrant, so that means that we have to make our final answer negative. So that's the answer to A. Okay, B. The tangent of negative 210 degrees. Let's draw a quick picture. So there's negative 90, negative 180, negative 210. Okay, so I'm in the negative third quadrant, right? So I'm going to go 210 minus 180, which gives me 30. And tangent is negative in the second quadrant, so the tangent of negative 210 is equal to the negative, because I'm in the second quadrant, the negative tangent of 30, which is negative root 3 over 3. And the last one in this example is the cosecant of 11 pi over 4. Okay, so 11 pi over 4. Well, the first thing I notice is that that's more than 2 pi. So I'm going to take away 2 pi. That's going to leave me with 3 pi over 4. Okay, so 3 pi over 4 is less than pi. And we're going to find the cosecant, which is the reciprocal of sine. So the sine of 3 pi over 4 is equal to the sine of pi minus 3 pi over 4, because our reference angle we get by subtracting from pi, which makes it equal to the sine of pi over 4. And it's positive because sine is positive in the second quadrant. So the sine of pi over 4 is root 2 over 2. Now remember, we're not looking for sine, we're looking for cosecant. And so the cosecant of 3 pi over 4 is the reciprocal of that. And if you rationalize that, you're going to get root 2. Okay, one last example. This time we're going to let theta be an angle in quadrant 2, such that the sine of that angle is 1 over 3. So there's theta, and since the sine is 1 over 3, that means that y is going to be 1, r is going to be 3, and we're going to use the Pythagorean theorem to get x. So 3 is equal to 1 squared plus x squared. And then I square both sides. So 8 is equal to x squared. So 2 root 2 is x. Now since we're in the second quadrant, x is going to be negative, y is going to be positive, and r is always positive. So the cosine of theta is x over r. That's going to be negative 2 root 2 over 3. And the tangent of theta is y over x. So that's 1 over negative 2 root 2. And that's how you use reference angles to find trig functions of any angle you can think of.